Okay, we're going to do a little bit of data analysis tonight, just initial data analysis. I think you'll like it. And we'll start out with a small data set. We have 2, 8, 5, 12, 10, and 4. And if I ask you to get the sample mean, you would say, okay, that's x bar, and that's going to be 2 plus 8 plus 5 plus 12 plus 10 plus 4, all over 6, because there are 6 pieces in the sample. And that's going to give you 41 over 6, or 6.83. Fair enough. So that's your sample mean. I see my color changed. Now, so if I want the median, the first thing I have to do is sort the data. And what we're going to do is, I'll show you how to do it when you have a tiny data set like this, and then there's a better way to do it when you have a large data set. But when I sort this, I'm going to have 2, 4, 5, 8, 10, and 12. Okay, so there's your data that is sorted. Now, when you have a small set, what you're going to do, you'll cross out the first one and cross out the last one. Then you'll move in and cross out the second and cross out the second to last. All right, in this case, you have 2 values left over. So to get the median, you're going to take 5 plus 8 over 2. That's going to give you 13 over 2, or 6.5. And the notation that we use for that is x subscript MED. So the median is equal to 6.5. Okay? Pretty straightforward. Now, for the next one, the mid-range, because you're going to use the largest value and the smallest value. So the mid-range, you're going to have small plus big over 2. Yes, there's a formula for this, but we're going to use this version. So the smallest value is a 2, the largest value is a 12. Add them up and divide by 2. That gives me 14 over 2, or 7. Okay? All right, so what we've done so far, those are your measures of central tendency: the mean, the median, and the mid-range. Now, in the next set, we're going to talk about measures of variability. So hang on for 1 second. We'll flip the page. One is just the range. See, I'm busy changing colors again. The range. And that's the big one minus the small one. So in this case, it's going to be 12 minus 2, or 10. Okay. The next one is variance, and it has a horrible, ugly formula. And we need to talk a little bit about how the ugly formula looks before we actually do it. So anyhow, if we have the summation sign, Okay, that's your summation sign. Essentially, that means add. So when we did our sample variance, or excuse me, my fault, our sample mean, I could have written x1 plus x2, plus x3 plus x4 plus x5. Oops. Sorry about that. Okay. Plus x5 plus x6 over 6. And that would have given me the 2 plus 8 plus 5 plus 10 plus, or excuse me, 12 plus 10 plus 4 over 6. Aha. But that's the same as saying the summation of the x's over 6. Well, we know how to do that. Let me just flip the page. That's just your 41 over 6, which is your 6.83, which we saw a minute ago. Sorry, just 1/3 we're using. Okay, fair enough. Now, I can also get the summation of the x's squared. So let's set out some columns and look at this. So I'm going to put these in order. It doesn't really matter, but I'm going to just order them because that's what we had. 2, 4, 5, 8, 10, and 12. And that represents the summation of the x's. That's your 41. Then you're going to have a column called the x squared column. So it's going to be 2 squared equal 4. 4 squared equals 16. 5 squared equals 25. 8 squared equals 64. 10 squared is 100. And 12 squared is 144. And when I add those up, I get 353, and that represents the summation of the x's squared. So you might be saying, why am I making a big deal about this? Well, I have to calculate my sample variance. And let me just change. And here is its horrid formula. That's lowercase script s squared equal to the summation of the x's squared minus the summation of the x's, the quantity squared, over n, summation of the x's, all over n minus 1. Okay, so in this case, we have 353 minus 41 squared over 6, the whole thing over 6 minus 1. All right, so that's going to be 353 minus 1681 over 6, the whole thing over 5, and that's going to give me 353, oh, sorry, hang on, 353 minus, let's see, let me change my page here, 280.17. I see I'm going wild with the numbers again, or with the colors again. Okay. So that's 280.17 all over 5. And that's going to give me 72.83 all over 5 or 14.56. So my sample variance is 14.56. Now, that's a very interesting concept, but the problem with it is it's in units squared. So if our original data set was dollars, this is going to be dollars squared, which doesn't make any sense, really. So what we're going to do is look at something called sample standard deviation. Okay, sample standard deviation, but that is very simple. Once you have variance, okay, to get sample standard deviation, that's just plain script s, and you take the square root of s squared. So in this case, you're going to take the square root of the 1456 and end up your 14 with 3.82. See, I've gone wild again. Okay, 3.82. All right, that should help you out.